Every single second, trillions of chemical reactions are firing inside your body. Your heart is beating. Your brain is sending electrical signals. Deep inside your cells, tiny power plants called mitochondria are turning the food you eat and the air you breathe into pure energy. But this process isn't perfectly clean. Every time your cells produce energy, they also create byproducts, unstable, highly charged molecules. Most are quickly controlled, but some escape. And when too many of these rogue molecules build up, they begin a rampage, attacking the very cells that created them. They tear at cell membranes, they twist and damage essential proteins, they injure the mitochondria themselves. And sometimes they even strike at the heart of the cell, your DNA. This microscopic, relentless assault is called oxidative stress. You can't feel it happening today, but over decades, this invisible damage accumulates, influencing how your skin, brain, heart, and every other organ ages. Today, we're going to shrink down, journey inside a human cell, and witness this process in action to understand how it happens and, more importantly, what we can do to support our body's natural defenses against it. So what exactly is this microscopic vandal? What is a free radical? To understand, imagine that every molecule in your body is built from atoms, and every atom has electrons. These electrons are happiest when they exist in stable pairs. But a free radical is a molecule with an unpaired electron. This missing partner makes it desperate, unstable, and highly reactive. It becomes a molecular thief. To stabilize itself, it will violently steal an electron from any nearby molecule it bumps into. The problem is, the victim of this theft, the molecule that just lost an electron, now becomes a free radical itself. It's now unstable and desperate, so it steals an electron from its neighbor. One reaction triggers another, and then another, setting off a destructive chain reaction that can cascade through a cell like falling dominoes. Many of these troublemakers belong to a family called reactive oxygen species, or ROS. But here's the crucial twist. ROS are not automatically the bad guys. Reactive does not always mean harmful. In fact, your body uses them for critical tasks. In controlled amounts, they are powerful tools. When you get an infection, your immune cells unleash a burst of reactive oxygen to destroy invading bacteria and viruses. Your cells also use them as tiny messenger signals to regulate blood flow, manage stress responses, and coordinate tissue repair. Even exercise plays a role. A good workout temporarily increases ROS production, and this is a good thing. That small, controlled challenge signals your body to fire up its own protective systems, making your cells stronger and more resilient over time. So the goal is not to eliminate every single free radical. That would be impossible, and it wouldn't even be healthy. The real problem begins when the production of these reactive molecules overwhelms your body's ability to neutralize them or repair the damage they cause. That imbalance, too much damage, too little defense, is oxidative stress. So where does this overwhelming burden come from? Some of it is just the cost of doing business, the price of being alive. The energy production inside our mitochondria is efficient, but not perfect. A few electrons always leak out and create ROS. But our modern world adds a lot more pressure. Ultraviolet radiation from the sun generates a storm of oxidative damage in the skin. Tobacco smoke is a direct delivery system for huge numbers of reactive chemicals. Air pollution, excessive alcohol, and chronic metabolic problems like persistently high blood sugar all pour fuel on the fire. Your body is designed to handle an occasional hit. The real danger comes from repeated, chronic exposure, combined with a gradual decline in our repair systems as we age. Let's follow this chain reaction and see what this damage actually looks like inside a cell. The first target is often the cell's outer wall, the membrane. This membrane is made of fatty molecules called lipids. Free radicals can attack these lipids in a process called lipid peroxidation, setting off that chain reaction across the entire surface of the cell. The once flexible membrane becomes stiff and leaky. Its communication receptors can stop working properly. It struggles to control what gets in and what stays out. Next, the damage spreads inward to the proteins. Proteins are the microscopic machines that do almost everything. They transport oxygen, build tissue, and repair damage. But their function depends entirely on their precise, three-dimensional, folded shape. Oxidation can chemically warp that structure. A damaged protein might fold incorrectly or stop working altogether. While young cells are great at clearing out this junk, this disposal system can become less effective as we get older, allowing damaged material to accumulate. Finally, the chain reaction can reach the control center, the nucleus, and the mitochondria themselves. Reactive molecules can damage our DNA, causing tiny errors or breaks in the genetic code. Fortunately, our cells have sophisticated DNA repair crews that fix most of this damage, but they're not perfect. And the mitochondria are at the very heart of this story. They are a major source of ROS, but they are also a primary target. When a mitochondrion gets damaged, its energy production becomes less efficient. This leads to more electron leakage, which creates more free radicals, which in turn causes even more mitochondrial damage. It's a vicious, self-reinforcing feedback loop. This cycle is a key reason why oxidative damage is so closely intertwined with the biological process of aging. Over years, this cellular wear and tear becomes visible across the whole body. In the skin, it contributes to collagen breakdown and wrinkles. In our arteries, it plays a role in the processes that lead to plaque buildup. In our muscles, it can reduce energy and slow recovery. And in the brain, oxidative damage is closely associated with cognitive aging and neurodegenerative conditions. So what can we do? We can't stop this process entirely, nor should we want to. The key is to shift the balance. We need to reduce the avoidable damage while actively strengthening our body's own defense and repair systems. The strategy is straightforward. First, reduce the heavy hitters. Do not smoke. Tobacco smoke is an overwhelming oxidative burden. And protect your skin from excessive UV radiation by using sunscreen and seeking shade. Second, build up your internal army. And this is not about popping a so-called miracle antioxidant pill. The evidence for high-dose antioxidant supplements preventing disease is surprisingly weak, and some can even be harmful. For example, high-dose beta-carotene supplements have been linked to increased risks in smokers. The most powerful strategy is to eat a wide variety of colorful vegetables, fruits, beans, nuts, and whole grains. These foods provide thousands of compounds that work together synergistically, something a single pill can't replicate. Consistent exercise is also crucial. Regular training activates your body's own antioxidant enzymes and repair pathways, making your cells tougher. Just be sure to progress gradually, as too much unaccustomed exercise can overwhelm your system. Finally, support your body's nightly repair crew. Consistent, high-quality sleep is non-negotiable for cellular maintenance. Limiting excessive alcohol and managing your metabolic health also go a long way in reducing unnecessary cellular stress. So, how do free radicals age your body? By starting microscopic chain reactions that, when left unchecked, can damage our cells from the outside in, from the membrane to the proteins to the very DNA and mitochondria at their core. Over a lifetime, this accumulating damage contributes to how our tissues and organs age. But the story isn't about eliminating a villain. It's about cultivating balance. Health depends on giving our body what it needs to manage this fundamental process of life. Move your body, eat real nutrient-rich food, protect yourself from known harms, and get good rest. Your body already has an incredibly sophisticated defense system. Your job is to create the environment where it can do its best work.